Hi everyone! From raw bricks to blazing fire, this project captures the art of building a giant wood-fired oven from scratch, where precision, patience, and a little sweat transforms simple materials into pizza-making magic. Every great oven starts with one very serious decision. Where in the backyard is this giant, fire-breathing masterpiece going to live? The spot has to be practical. It needs solid ground, safe distance from fences and plants, and enough open space so smoke can rise without turning the backyard into a fog machine. Wooden boards are carefully cut and assembled into a sturdy rectangular mold. This frame defines the footprint of the oven's foundation. The boards must be straight and firmly secured so they don't bow outward once the concrete is poured. Inside the wooden frame, a plastic sheet is spread across the ground. This layer acts as a moisture barrier, preventing water from seeping into the soil and weakening the slab over time. On top of the plastic, a metal reinforcement mesh is placed. This steel grid gives the slab internal strength, helping it resist cracking under the heavy weight of the brick dome that will eventually sit above it. With everything in place, the concrete is mixed and poured into the mold. It flows around the steel mesh, filling every corner. The builder spreads it evenly, making sure there are no air pockets or low spots. Then comes the satisfying part: smoothing and leveling. Using a straight edge and trowel, the surface is carefully leveled to create a flat, even platform. This step is crucial. A perfectly level base ensures that the oven structure above will sit stable and balanced. The concrete blocks go down in neat, horizontal rows, with the vertical joints staggered like a brickwork zipper. This isn't just for looks. It spreads the weight evenly, so each block leans on its neighbor like a well-organized team effort. Masonry is basically group therapy for bricks. Every layer gets checked for level and alignment, because if the base is even slightly off, that tiny mistake grows taller and prouder with every new row. And nobody wants a leaning oven stand that looks like it's questioning its life choices. Once the stand is solid, plywood panels are secured across the top to create formwork for the concrete slab. Sideboards are fastened around the edges to shape the thickness and keep everything crisp and tidy. With the mold ready, a sheet of steel mesh is placed inside for reinforcement, the hidden skeleton that keeps the slab strong. Concrete is poured in stages, spread carefully to surround the mesh and fill every corner. After curing, the wooden forms are removed, revealing a single, solid slab bonded seamlessly to the block base. Clean, heavy, impressive. Now comes the oven floor layout. A large sheet of tracing paper is rolled out, and using a tape measure like a giant compass, a perfect circle is drawn to match the oven's internal diameter. This template gets transferred directly onto the slab to ensure the dome will sit perfectly centered. No guessing, no close enough. Precision matters, especially when your future pizza depends on it. Ceramic insulation boards are cut according to the template and arranged on top like a puzzle. These boards create a thermal barrier between the structural slab and the high-temperature cooking surface. Around the perimeter, thin metal strips are fixed in place to contain the next refractory layer. Attention then shifts to the entry arch. Curved plywood pieces are cut, reinforced, and assembled into temporary formwork that defines the doorway. This arch isn't just an entrance. It controls airflow and supports the dome structure. In short, it's the oven's lungs and front door rolled into one. The first course of refractory fire bricks is carefully cut and shaped with an angle grinder to follow the circular outline. This base ring sets the tone for the entire dome. Each brick is laid in high-temperature refractory mortar, mixed on site with careful water control to avoid weakening the blend. Too much water can cause shrinkage cracks once the oven fires up, and that would be a heartbreaking plot twist. As the first and second courses rise, they interlock with the entry arch, tying everything into one cohesive structure. Each brick is angled slightly to create a smooth inner curve, helping flames flow efficiently across the dome. This stage might look repetitive, but it's critical. A wood-fired oven dome works on compression. Every brick pushes against the next, distributing weight in a continuous ring. If one brick shifts out of alignment, the load path changes, and uneven stress can cause cracks over time. That's why the arch formwork is so important. It keeps the geometry honest, guides the curvature, and locks the lower courses into position. In masonry, details matter. One crooked brick today could mean dramatic oven therapy tomorrow, and nobody wants that. If the entry form isn't perfectly upright or ends up a little too wide, the next rows of bricks have no choice but to follow that mistake. And bricks, bless them, are obedient little things. They'll follow bad leadership straight into structural chaos. But when the formwork is accurate and square, it becomes a reliable guide. Every brick can be pressed against it with confidence, keeping the dome's curve consistent from the first ring all the way to the keystone. At this stage, cutting the fire bricks precisely becomes crucial. This isn't backyard wall building, where you can hide imperfections under thick mortar. A wood-fired oven demands tight tolerances. The dome needs to behave like one solid shell, which means the bricks must fit snugly together, with minimal wedge-shaped gaps. Too much mortar is actually a problem. Mortar isn't as strong or heat-resistant as fire brick, so thick joints create weak spots. By trimming and beveling each brick to match the dome's curve, the builder ensures that compression flows cleanly from brick to brick, like a perfectly coordinated group hug under extreme heat. With the entry arch and first perimeter courses secure, the dome begins to rise. This is where basic bricklaying transforms into engineering. Each new course tilts slightly inward. Many builders use a pivoting arm fixed at the center of the hearth to check that every brick leans toward the future apex. It's basically a compass for bricks, making sure the dome doesn't slowly spread outward like a tired pancake. As the dome narrows, the bricks require more shaping. Standard rectangular bricks don't magically form perfect circles, so their sides are cut or beveled to eliminate gaps. The higher the dome climbs, the more custom each brick becomes. Meanwhile, the entry arch needs reinforcement. Unlike the dome, which distributes compression evenly in a circle, the arch carries concentrated loads and faces direct flame and exhaust. It works harder than it looks. As the dome approaches closure, precision becomes everything. The opening at the crown must be calculated carefully. Too wide, and you end up with a giant mortar plug. Too tight, and forcing the final bricks into place can introduce stress cracks that travel downward. When properly set, the keystone bricks lock the entire dome into equilibrium, the ultimate "we're all in this together" moment. To support the upper courses while the mortar sets, an inflatable ball is used. Traditionally, builders crafted elaborate wooden frameworks, but that takes time and lumber. A large inflatable ball offers a smooth, adjustable surface with far less effort. Pump it up, position it, and it gently supports each freshly mortared brick. It's low-tech genius. Once the brickwork is complete, the exterior is coated in a thick, clay-based render. This seals joints, prevents air leaks, and adds a stabilizing skin while curing continues. At the crown, the keystone joint is packed carefully with refractory mix and finished smoothly. After curing, the ball is slowly deflated and removed. Additional bricks reinforce the entry throat, interlocking it with the dome. And remember, the arch isn't just a doorway. It's the control center where flame, fuel, and airflow meet. In other words, it's where the magic, and the pizza, happens. The entry and chimney area aren't just decorative add-ons. Their geometry basically decides whether this oven becomes a smoke-belching drama queen or a perfectly behaved cooking machine. The opening has to pull smoke out efficiently, hold heat inside like it's guarding treasure, and let flames sweep across the dome in smooth, even waves. No pressure, right? To make that happen, the arch form stays locked firmly in place while each brick is cut into a precise wedge. When set together, they follow the curve without awkward gaps. It's less stack and hope, and more surgical brick choreography. Installing the chimney pipe marks a big moment. This isn't just sticking a tube on top and calling it a day. Airflow is everything in a wood-fired oven. The flue must act as a controlled exhaust system, creating draft while keeping the cook from looking like they just lost a fight with a campfire. By placing the chimney at the front above the entry, flames are encouraged to roll dramatically across the dome before heading upward, which means better heat distribution and happier pizzas. The chimney pipe is typically stainless steel, chosen because it doesn't panic under extreme heat or rust after a few rainy days. Around its base, extra fire bricks are stacked to stabilize the pipe and anchor it securely into the structure. Now comes the part that separates a decent oven from a heat-hoarding superstar: insulation. The brick dome might already be self-supporting, but without insulation, all that precious heat would escape faster than guests when chores are mentioned. A ceramic fiber blanket is wrapped around the dome in overlapping layers, usually 2 or 3 thick. This material is designed to trap intense heat inside, while keeping the exterior surprisingly cool. Seams are staggered, so no continuous gap allows heat to sneak out. A metal band around the base keeps the blanket snug, while wire mesh compresses it firmly against the brickwork. The mesh also creates a textured surface for plaster to grip onto later. Every edge is sealed carefully to eliminate heat leaks. Done properly, the oven interior can hit 400 to 500 degrees Celsius, while the outside remains close to normal air temperature. That's thermal efficiency at its finest. Next, a dense mortar coat is applied over the mesh. Pressed firmly with a trowel and smoothed in stages, it forms a rigid protective shell around the insulation. The surface is shaped into a smooth curve, which not only looks beautiful, but helps guide heat and airflow evenly. Around the entry, extra care ensures the plaster blends seamlessly into the arch. No cracks allowed where dome meets throat. With the dome sealed, attention shifts to the front hearth. Perforated black bricks are installed as edging around the entry, protecting the slab and forming a sturdy apron. Then comes the finishing touch: large ceramic tiles. Carefully measured and cut, straight edges frame the apron, while curved cuts hug the oven's rounded base. At this stage, the oven isn't just functional, it's starting to look like it belongs in a rustic cooking magazine. And honestly, it earned it. The tile edges are carefully smoothed, so they don't chip the first time someone drops a pizza peel with dramatic flair. These tiles will form the outer layer of the hearth, so they need to look good and survive real-life kitchen chaos. Once cut and polished, they're dry-fitted around the oven base, alongside slim aluminum or steel edging profiles. Those metal trims aren't just for style points. They protect the tile edges from bumps, knocks, and the occasional overconfident elbow. To secure everything, a powdered adhesive mortar is mixed to the perfect peanut butter consistency. Spread with a notched trowel, it creates neat ridges that help the tiles bond evenly to the slab. No hollow spots, no wobbles. Each tile is pressed firmly into place, adjusted, tapped, and leveled until the surface becomes one smooth, continuous workspace. This apron isn't just decorative flair. It extends the working area in front of the oven, creating a heat and ash-resistant zone for sliding pizzas in and out, setting down hot pans, or dramatically presenting your masterpiece to impressed friends. If you zoom out for a second though, this isn't just about tiles and mortar. Wood-fired ovens like this trace their roots back thousands of years. Ancient builders in Mesopotamia and Egypt were already shaping clay and brick into vaulted chambers designed to trap and radiate heat. The Romans refined the idea, perfecting masonry ovens with thick walls and graceful arches. By the 18th century, Naples embraced the wood-fired dome as the ultimate pizza machine, and the rest is delicious history. The genius is simple. A heavy masonry shell absorbs heat, while a low, curved ceiling forces flames to roll across the surface before exiting through a vent. That creates both radiant and circulating heat, ideal for blistering crusts in minutes. This modern build follows the same timeless principles. Thick fire bricks create thermal mass, and the dome shape optimizes airflow, just like its Neapolitan ancestors. Sure, today's ceramic fiber insulation and heat-resistant mortars make it more efficient and durable, but the core idea hasn't changed. It's still geometry plus fire plus craftsmanship. In the end, this oven isn't just a backyard project. It's a continuation of a tradition that's been feeding people with flame for over 2 millennia, just now with better tools, and hopefully better pizza toppings.